Seals come in two parts, the head and the seat. The head is part of the spring assembly and it usually mounts on the shaft. The seat is not part of the spring assembly and usually mounts in the bore. The best way to ND the shaft size is by measuring the actual shaft seal mounts on, but if you only have a sample, then measure the inside diameter of the head to ND the shaft diameter. You can at approximately 0.010 inches to 0.020 inches for rubber squeeze shaft size head seat. The best way to identify the seal head type is by cross-referencing as follows: DMR John Crane Cello Pack. Seal type A, type 6, type A, type 16, type B, type 6A, type B, type 68, type C, type 21, type 43, type 21, type D, type 2, type E, type 1, type 43, type 51. If you are unable to obtain this number, then the best way to identify the seal head type is by visual imaging the sample to a drawing or picture. In this tutorial, refer to pages 5 and 6 for a list of pictures depicting the various seal head types. These detailed pictures and drawings are also included in the DMR Shaft Seals Catalog. This is easy. Just measure the outside diameter of the seal head assembly. These numbers do not have to match up exactly because the purpose is to ensure there is enough clearance for the replacement seal. Make sure the DMR replacement seal head does not have a larger OD than the sample or the chamber it is ting into if you have access to the actual equipment being seal head type seal head OD. 2T1C010. 3. The seal head OP. Height. Operation height is the height or length of the entire spring assembly and head compressed and installed in the equipment it is sealing. It is also a measure of how much spring force is applied to the two mating faces. If the force is too low, then it may leak, and if it is too high, then it will wear out quicker. The best way to measure this dimension is while the mechanical seal is installed in the equipment. Another option is to reuse the old spring if the heads interchange exactly and if the old spring isn't corroded. If neither of these two options are feasible, then you can use the formula below as a general guideline. However, this applies to DMR mechanical seals and may not apply to other manufacturers' seal head OP. HT. In other words, the springs are generally compressed to approximately half the length for installation OP. Height. Total spring assembly unsprung 1/2. The unsprung height of just the spring. Refer to page 5 of this guide for a list of pictures depicting the various seal seat types. The best way to identify the seal seat type is by visually matching the sample to drawing or pictures. Note: seat type 1, cup mount, and seat type 3, O-ring mount, are interchangeable. Measure the OD of the seal seat and you can subtract 0.010 inches to 0.020 inches for rubber squeeze. You can skip this step and just call it MOS or mount on shaft if you have already ID'd the seat as a type 8, 9 or 11 seal seat type. Seal seat OD. Measure the seat thickness. Seal seat thickness 3T1C010. Way to select proper materials is by asking what liquid is being pumped and at what temperature. The seal material recommendation chart included with this tutorial can be used to select a suitable group of materials, and in some cases it may even work better than the original seal. The list starts with the most portable seal on the left column, and you should also confirm that the working temperature is compatible with the elastomer limits at the bottom of the chart. If you are unable to ND out the working environment of the seal, then the only option is to visually identify the material and match it to the information on page 5 of this guide. Material code working from left to right. Starting with the shaft diameter, you should now be able to identify the DMR part number. There can be more than one option based on UID compatibility or the interchangeability of seat type 1 and 3, so you should write down each of these numbers so you have as many options as possible for % availability.